Ever wonder how AI models like Pangu Pro MoE achieve such remarkable versatility, mastering math, coding, and complex reasoning? Let's dive into the breakthroughs that make this possible. The journey begins with the training process. Imagine a curriculum designed for peak performance. The model starts with 16 million tokens of data, then gradually reduces the learning rate, a technique called annealing. Think of it as dialing back the intensity of a workout as you build strength, ensuring the model balances speed and stability without overloading. But here's the key innovation. This isn't just any training. The team leveraged Huawei's Ascend 800TA2, a chip packing 256 teraflops of processing power. It's like a race car engine in a compact car, efficient, consuming just 310 watts, far below its peak. This hardware enables faster training without the energy costs, setting the stage for groundbreaking results. Now, how do you teach an AI to think rather than just memorize? The answer lies in supervised fine-tuning. Picture a student solving a mix of easy and complex problems. Here, the model tackles 75% reasoning tasks, like math puzzles or code generation, and 25% general tasks. This dual focus sharpens its ability to reason deeply, not just match patterns. But it's not just about data. The team used a two-stage approach. First, the model masters basic instructions, then gradually tackles complex reasoning. It's like learning to ride a bike before doing tricks. This prevents catastrophic forgetting, where the model loses old skills when learning new ones. Here's where it gets clever: checkpoint merging. Instead of merging separate models, they combine snapshots from the same training run. Think of it as compiling a yearbook from different school years. Each snapshot captures unique growth, and blending them creates a stronger, more versatile model. Then there's reinforcement learning. The model learns from rewards, but here's the catch. If all answers get the same reward, it stagnates. The solution? A zero-advantage mask that filters out unhelpful data, letting the model focus on what truly teaches it. The result? A 35% boost in training efficiency, thanks to optimized pipelines and custom operators like Mull Attention and Swift GMM. Every detail was fine-tuned to make the model faster and smarter. So what's next? Pangu Pro MoE isn't just about size. It's about creating an AI that thinks, adapts, and excels in ways we're only beginning to understand. Stay tuned for more deep dives into the future of AI. But let's zoom in on the model's architecture. Pangu Pro MoE uses a mixture of experts approach, where only the most relevant experts handle each task. This means it uses just 22% of the parameters of dense models during some steps, acting like a lightweight AI that still delivers powerhouse performance. Numbers tell the story. In the prefill stage, it processes 2,000 word inputs in 1.94 seconds, blazing fast. In decode mode, it handles 1,528 tokens per second per card, outperforming older models by nearly 100%. Pair it with the Ascend 300i Duo chip, and you get low-latency responses even under heavy loads. What about accuracy? Even when compressed to 8-bit precision, it loses just 0.8% on math tasks, a near-lossless trade-off. With 16 billion activated parameters, it matches top-tier models while using half the resources. This isn't just speed, it's smarter design. Pangu Pro MoE proves that efficiency and power can coexist. By grouping experts and balancing their work, it redefines what's possible in AI. Whether solving math problems, generating code, or understanding language, this model is a testament to innovation. The future of AI isn't just bigger, it's smarter, faster, and more sustainable.